Hi everyone. So this was a problem that was requested. Made me realize that, oh crap, I got a demo I got to show you guys. But basically the problem that was requested was on homework. I think this is 6B, number 25. So chapter 6, problem 25. It says you hold a bucket in one hand. The bucket is in the bucket is a 500-gram rock, so that's the mass of the rock. You swing the bucket so the rock moves in a vertical circle in a 2.2 meter diameter. Vertical circle, 2.2 meters in diameter. Ooh, gotta be careful there. Yeah, diameter. That's that is not radius, so I need to be careful. So basically, this distance, diameter, is 2.2 meters. So that means then the radius is going to be 1.1 meters, right? It's half the diameter. Okay, so it says, what's the minimum speed the rock must have at the top of the circle? So that's what I'm looking for, is the minimum speed at the top of the circle to always stay in contact with the bottom of the bucket. So basically, this is basically one of those questions that, well, let's think about what, so if we had a rock that was in a bucket, so like here's my bucket. Yeah, sure. And the rock was in the bucket. What forces would be holding the rock to the bucket at the peak here? Well, there's definitely going to be the weight, like we've seen in class. And then there's also going to be the normal force. So then I could do Newton's second law. That'd be F net equals ma. It's a terrible F net. Net equals ma. Again, remember, if we have a circle, the convention, the best way to do this is to make the center of the circle the positive direction. So that means in that case, downward is going to be the positive direction and upward is going to be the negative direction. So really I just have both these forces, the normal force and the weight, pointing in the positive direction. So it's going to be mg plus the normal force is equal to the mass times the acceleration, but I'm moving in a circle, and we know that things moving in a circle is a centripetal acceleration, and the acceleration is v squared over r. So I'm going to replace the acceleration with v squared over r. Now, the last thing really left to do here is that it's talking about the minimum speed required. So we've done this for a couple of problems already in class. Similar to this is that the minimum speed required, we saw like for when we were spinning the ball on a string, that the string slacks when if we don't have enough speed, right? Or we've talked about on a roller coaster that if you don't have enough speed, the normal force actually goes to zero. And this is exactly going to be the same thing with the rock and the bucket, is that the normal force for the minimum speed, the slower I go, the less normal force I get. And so for the minimum speed to occur, really all I have acting then is the gravitational force, because that would be the minimum requirements to have it keep going in a circle. That's causing the centripetal force there if Fn is 0, but be at a minimum speed to do that. So basically, normal force is going to go to 0, and I get that the weight is equal to mv squared over r. Interestingly enough, mass cancels out, so I never really needed that 550 grams to begin with, and I can isolate the minimum speed, multiply both sides by r. I get one of my favorite solutions, GR, but GR equals v squared, so I'm going to take the square root of GR, and that's going to be my velocity. So I'm going to get the square root of baby g is just about 10, and then the radius they told me was 2.2. No, it wasn't. It's 1.1. Careful, Mr. Fournier. 1.1. So it's going to be the square root of 11. Got no idea what that is. 3.3. A lot of double digits here. So 3.3 meters per second. That's my speed. All right, hope that helps. All right, bye.